Hi there, this is Mr. Sand. I'm coming back at you with some information about electrons in bonds. So, today we get to introduce you to three different types of bonds. One type is ionic, another type is covalent, and another type is metallic. I think that's the same order that you have on your sheet. Let's check that out. We have covalent, ionic, and metallic. Let's check this out again here. Oh, they're reversed. So I'll erase it real quick and rewrite them. So we've got covalent, ionic, and metallic as our types of bonds. Right. Covalent, ionic, and metallic. So what I want you to know about these things, first of all, is that for covalent bonds, when you make a covalent bond between two atoms, the result is something we call a molecule. So it's when two atoms come together and they form a covalent bond, that resulting structure is called a molecule. When two or more atoms get together and they form an ionic bond, it's kind of strange. They call it something that you might not have heard before. It's called a lattice. Not lettuce, a lattice. Lattice. And finally, metallic. In a metallic bond, whoa. In a metallic bond, if two or more metals come together, they call it a complex. Okay, that's just the starting kind of vocabulary. A molecule, lattice, and complex. Molecules, you can have molecules that are just two atoms. An ionic bond lattice with just two atoms, that's very rare. Normally they're in these large large arrays. And the same thing for metallic bonds. They're in large structures. Covalent bonds seem to be the smallest here. So that's just to get you started. Now I'm going to go to your little worksheet here. I'm going to use this. I'm going to drop this in here. Right. So I want to describe what the electrons are doing in each one of these structures. So here you've got an atom, and there you've got an atom, and the electrons, I have this diagram in here to show you that the electrons, let's say this is the electron right here, it's attracted to its own nucleus, and it's attracted to the opposing nucleus. And here the electron's attracted to this nucleus and attracted to this nucleus as well. But the nuclei of these two atoms repels each other. So there's this balance between the attraction and the repulsion right here. So with the electrons here, the electrons are shared. Electrons, that's my little abbreviation for electrons. Electrons are shared between these two atoms. For the ionic bond, if you've watched the video, you know about the harpoon mechanism where one atom spits out an electron and that makes this one then I guess would be negative and this one would be relatively positive. Then that attraction between the positive and the negative atom causes the bond. So this right here, you could say the electron is stolen by one of the atoms, and the resulting charge difference, the positive right here and the negative right there, that's what makes the attraction. Okay, so the electrons is involved, but it's more about the resulting charge. So this makes this whole atom over here more negative, and it makes this atom over here more positive. So that positive and that negative, they attract to each other. And then finally over here, the electrons are in a sea of electrons. So the description here of the electrons here are just flowing around like crazy. They're going over here, here's an electron over here. They're just free-flowing electrons. It's kind of like a soup or a sea of electrons. They're just flowing around like this. And they're relatively negative, this little sea of electrons here, and they've got these positive nuclei of metal atoms that are just kind of embedded in here. And that keeps them, it gives them a whole bunch of properties that we're going to see here in a few seconds. So let's go to the properties then. I've got a first property. The first property here that we want to talk about is conducting heat. So what bond conducts heat? Well, to conduct heat, you need to be able to move. So if you look at these atoms right here, I'll go back to this. If you look at these atoms right here, these are fairly locked in place. These, if they're in a lattice structure, so this right here, there's just two atoms stuck together, but if we put them in more of a lattice structure, so I'll just draw two more over here, so this would be a positive nuclei, and this would be more of a negatively charged atom right here. Right. And then these would be attracted to each other as well. These atoms are fairly locked in place. So as far as atoms moving around, these are kind of stuck. These are kind of stuck. And these, well, you can you can kind of push these around and wiggle them around as much as you like. So you had to write over here, you have to do this. You just have to see. It's got to be conducting heat over here. So this is a property of metals. Conducts heat. I don't think I labeled these. This is metal or metallic bond. This is ionic. And this is, of course, covalent. By the way, the word co and valent right here tells you about the electrons. They're in the valence shells of these atoms, and they're both sharing them, so it's covalent. All right, next property we have. So we've done conduct heat. Let's go to the next. On down. Conducts electricity as a solid. So to figure this one out, we got to think about what electricity is. All right, so what is electricity? Have you ever thought about what that means, electricity? Sure, you've probably seen that, turning something on, electricity flows through it, right? Or maybe an outlet in your wall. You think about what that means, where the electricity is coming from. What does it do? What electricity? That's a strange question. Well, all electricity is, I'll write it down here. All electricity is let me write this, not the. Electricity is electrons flowing. That's it. That's all electricity is. When electrons flow through something, they often do work as they flow through something, so that gives you some kind of change in a system, which is really good if you're driving a car. You want to have those wheels move, so it's really down to the electrons pushing things around so that these wheels move. But electricity is just electrons flowing. So in these different bonds right here, you've got the covalent bond, you've got ionic bond, you've got metallic bond. Which one of these do you think is going to flow which one's going to allow electrons to flow through it? Well, covalent bonds, you've got them kind of locked in place. Here, they're kind of locked in place as well. The atoms are locked in place, and the electrons aren't moving between them. But over here, we've got a sea of electrons, so it's going to conduct electricity. You better believe it. Conducts electricity. And that should make sense to you too. Both of these should make sense. I haven't given examples of these, but I can. Conducts electricity, wires, what are they made out of? They're not made out of covalent bonds. They're not made out of cloth. They're made out of metals. So metallic bonds like copper wire is great as a great conductor of electricity. Also conducts heat. Think about when you've got something on the stove, let's say a pot on the stove, you don't want to touch that metal pot on the stove, do you? Because it will conduct the heat right to your fingers, and that will hurt. So both of these properties right here, conducts heat and conducts electricity, they belong to metallic bonds and not the other kinds of bonds. Although I have to say that there are exceptions. There's always exceptions.